Hello guys, welcome to Inside Electronics. So in today's episode, I'm in a little bit unusual recording area, and that's because of all the mess that is up there in my workbench. I was not able to manage. I managed to fit all these in my table. So everything is down here. So today let's see how you can check whether your car or bike battery is good or bad. So what happened is that today when I want to go for a ride and when I turned the key on in my bike, nothing happened. The battery low indicator came on and bike just refuses to start. Nothing works. So that usually happens because of a couple of reasons, and the most common reason is a battery failure. And given the fact that I was not using my bike for a month, it is pretty common to for the battery to get discharged on its own. So let's see in this video how you can check whether your battery is good or bad. So as I said, there are a couple of reasons how a battery gets flat when it is not used for a long period of time. The first and most obvious reason is that it's very common that every battery has an internal resistance of its own, and a fully charged battery, when just left untouched for a long period of time, can gradually get discharged on its own. There is nothing needed for as a load. The battery itself acts as a load and it will get discharged. And the second thing is that even though when you turn the bike or car the key off, the battery is not fully disconnected from all the electronics and electrical systems in your car. The battery is still connected to all the electronic stuff in your car or bike. That's how it detects when you press the key fob, and that's how it detects when the security system is activated. So everything is still connected to the battery. So those things will actually drain a few charge from your battery, and combine that with the internal resistance, internal drop. So those two is the first reason why a battery gets discharged on its own. The second most common reason is that you equipped your car or bike with a non-standard accessory. The battery can actually be drained because of either the accessory is faulty itself, or the person who done the wiring for the accessory does not know what he was doing, and he just caused some issues in the wiring that causes the battery to drain itself. So that are the two things that happens. And if your car or bike does not have any non-standard accessories, then that chance can pretty much be neglected. But the next two things is also should be considered. Now the second most reason the battery fails is because of the chemistry of the battery itself. Now these are lead acid batteries, sealed lead acid batteries, and these one are specifically called SMF batteries, that is sealed maintenance free batteries, because these batteries do not need the usual electrolyte top-ups like the other batteries do. So these are SMF batteries, but these still are sealed lead acid batteries. So that means because of all the chemistry that's happening inside it, because of the chemical reactions, the plates between the positive and negative electrodes has a lot of plates inside it, and because of the chemical reactions happening, there is a chance for a short circuit to be built across the terminals inside the battery. And a short circuited battery can easily be detected by using a simple load kind of stuff, which I'm going to show you. So a short circuit in the battery results in a pretty much useless battery. So that is the second reason. Now the third reason is that the electrolyte inside the battery has lost its capacity. Now in the regular batteries, that is the time when you want to replenish your electrolyte with battery water, or the I forgot the actual name for that water, deionized water, yeah. So that's the time when you top up the battery in the regular case. But these are sealed batteries, so there are no way you can top up these batteries without physically breaking apart some bits and pieces of the battery. So those are the three major reasons your battery gets discharged on its own without anything at all. So for checking your battery is good or not, you need a load. And here in my case, I'm going to use a very simple light bulb like this one. This is a 12 volt 35 volt watts bulb. You can see right here it's a 12 volt 35 watts bulb. So for testing for short circuit is really simple. You can see this meter right here shows the battery voltage, and this meter is going to show the battery charging current. So take a look at the meter reading right now. It's 11.2 volts at the moment, which is really low, and it is showing 11.2 volts because I was charging this thing for an hour or so. So it gained some charge. Before that it was reading around 9 or 10 volts. So right now I'm going to connect this load. This is just a standard light bulb across this, and you can pretty much see the bulb turns on, but look at the meter, the voltage is dropping to 5 volts. But because the bulb is on and the voltage is still showing, that indicates that this battery has no internal short circuit. Now if the battery had an internal short circuit, then the voltmeter should be showing 0 volts and the bulb will not turn on. It may read 12 volts open circuit. That means if no load is connected, it may read 12 volts right there, but the moment when you connect the load across the battery, the voltage will be 0. I'm not saying 1, 2 or 3 volts, the voltage will get 0. So if that is the case, then pretty much you cannot do anything else. Just discard your old battery, exchange it for a new one. That's the only thing you can do. Now the remaining two things, because now we have detected that this battery has no internal short circuit in it, we are now down to two reasons. The first one is that this is now having the regular discharge cycle. That means because I was not using it for a month, it just discharged on its own, and that can pretty much be fixed with a simple charging circuit like this. If that is the case, by tomorrow, right now I have turned it off. So if that is the case, if the battery has discharged on its own without any issues, we can recharge the battery back to its normal working condition by tomorrow. But if the issue is the third one, that is if the electrolyte inside the battery has lost its capacity, then once the battery is fully charged, it is not going to see like what I'm going to say. Yeah, the battery is not going to hold on to that voltage for a really long time. Like if once the battery is fully charged, I can use this test load to connect across the battery, and it should still read 12 volts when the load is connected. Given the fact that this battery, as you can see right here, is a 12 volt 9Ah battery, which means this battery can supply 9 amps of current at 12 volts for 1 amp. Being a simple load like this connected across, it should not drop the power significantly. So I'm going to charge this battery right now. This is a pretty simple setup that I'm using right here. This is a 12 volt 3.2 amp transformer, and I have connected that to the bridge rectifier circuit right here. This setup right here, this is the rectifier block connected to a heatsink, and across it is a capacitor, and we have connected a meter in series with the output of the bridge rectifier just to measure the charging current. And this right here, I'm connecting it to the battery. You can see I'm connecting it to the battery right here, and it's my screwdriver right. So we are now measuring both the voltage here and the charging current right here. So I'm going to turn it on, and you can pretty much see the charging voltage is around 14.7. It's going to settle around 15 volts. It's fine, and the charging current is only 210 milliamps. A 9000 milliamp hour battery charging at only 200 milliamps per hour, it's going to take a long time for it to fully charge. But the low charging current means we are not going to boil the electrolyte faster. So I'm going to leave it as it is right now for a couple of days. Once the reading gets 0, we will know that the battery is now fully charged. So if the battery can stay at 12 volts for a long time after connecting this load across it, then that says that the battery is fully working back to normal and it is now back to normal life. we can connect it back to my bike and check later. But after a fully charged, when I connect the load, if the battery voltage drops quickly, just like we see in here right now, that indicates the electrolyte is fully used up and the battery needs to be serviced by an authorized service center. So I'm going to leave this as is at the moment. By the way, this circuit right here is a pretty simple bridge rectifier circuit. As I mentioned, I will put the circuit diagram in the screen right now, and yeah, and once the battery is fully charged, I'll be back and we will see what exactly is the reason. So this is the second day of me charging the battery. It's been around 24 hours since I've left this thing on charge, and as you can see on this meter, the charging current has dropped significantly. Now it's just around a couple of milliamps. So right now I'm going to turn off because the charging is almost complete, and I have now turned off. You can see on this meter right here the voltage is coming down gradually. So now I have my test load right here. Now notice that I have connected the two wires together on this one, which makes both the filaments will come on when I connect this to the battery. This being a 35 watts load, together they are going to be a 70 watt load, and it's going to draw around 6 amps from this 12 volt. So what should happen is that if the battery is okay, then being a 9Ah battery, it should be capable of providing the necessary current without much of a voltage drop at all. So if the battery can hold with that current for some time, then it clearly says that the battery really is a good one. So I'm going to test the load right now. The voltage is now dropping to 10 volts, and it is actually going down pretty much. It's going, it just became 9.82 right there, and it is staying at that point. And I'm assuming because it is staying at that moment itself, even though 9 volts is still low, I think we can make this thing work, because it shouldn't be getting down to 9 volts. It was supposed to be at around 10 or 11 volts, but it was getting too low. So I guess this battery is really bad. The electrolyte has lost its capacity over time. There's only one way to find out. We are going to connect it to my bike and we'll see what happens.